let us discuss the next topic is, here it is about lens formula derivation. So for that, just in the ray diagrams we have discussed many situations. That means when you change the position of the object in front of the lens, that image position also changed, and that characteristics are given by the lens is differently. So any situation you have to consider, put the object on the principal axis, then here for that just you have to give a relation between the object distance, image distance, and the focal length of the lens. So before that, who is that? Just mute yourself. If I find you, I will remove you directly from the class. Mute yourself. Okay. So look at the situation what I am creating here. Just I need a principal axis. Then I will identify the midpoint on that axis to put the lens. So here look at that point I got, that is principal axis for me. Then that point is pole. Then construct your lens here. Okay, I got a double convex lens on the screen now. Next, identify its focal points. Name them as F1 and F2 respectively, depending on the surfaces. Right. Then next, you required object here. So on the principal axis, wherever you can put that object, but it is outside the focus. Right. Look at here. I am going to select the position of object here. Let me take that object position is O and O dash here. Right. So object is placed with a certain height O dash at a point O on the principal axis. So here when you put the object at this position, where its image will be formed by the double convex lens. So we have to find out that by the rays. So what are the rays we are going to select here? One is parallel to the principal axis and the other ray passing through the optic center of the lens. Let us consider the two rays from the top of the object as we discussed in the rules of ray diagrams. Right. So parallel ray is drawn parallel to the principal axis. Parallel ray means here the ray is parallel to the principal axis. So constructed and incident on the double convex lens. Then I required here second ray, that which started from the top of the object from the same point, that is passing through the optic center of the lens. Then you know the behavior of these two light rays, right? The ray which is passing through the optic center of the lens, it remains undeviate. It remains undeviate. So it goes in the same path without any deviation. Then what about the ray which is parallel to the principal axis? After refraction, that ray passes through the focal point. The ray passes through the focal point of the double convex lens. So here let me complete that one. Then I got the converging point of these two refracted rays. So from there I am going to draw a perpendicular onto the principal axis. So that converging point identified by me as I dash. So that I dash is the image point of O dash. Then what about the O image? It will be on the principal axis. How do you find out? Here just constructing the perpendicular onto the principal axis. That principal axis and the image, that perpendicular line coincides each other. That point is the image of the point O here, that identified as I here. Right. Then here simply I got the image and that size is I dash height. Okay. Then here look at left side, I am drawing a one blue color line from pole to the object position. Right. So the line simply measuring distance. The length of that means PO length is what? It is the object distance. So object distance now denoted by the letter U here. U measures object distance. Then look at here, right side also I am drawing one line, that is from pole to the image point, P to I. So that pi measures the image distance, then it is denoted by the letter v here. I got the object distance and image distance. Pole to the object, that is called the distance between pole and object is called object distance. The distance between the pole and the image is called image distance. They are respectively denoted by u and v. Then next, look at here one more line from that lens drawn towards f1. Pole to the f1. That pf1 measures focal length of the lens. That is denoted by the small f. Right? Small f is the focal length. That focal length is measured between the pole and the focus f1. Okay. So these are the three measurements I have shown. Then you know already sign convention rules, right? Here that sign convention rules in the direction of incident light ray taken to be positive. So that object is left side and the incident light ray moving towards the right side onto the lens. So after refraction also it is in the direction of light ray, that measurements. Black colored arrows shown. Right? So that will give you the positive direction to measure the parameters. Right? So here according to this situation, focal length and image distance will become positive. Right? Then here what about u? Object distance will be measured as negative because opposite to the incident light ray. These are the parameters I am explained in this. So here that figure number 19 explanation is completed. Right? Now we are deriving the formula that which gives the relation between the image distance and the object distance. So just let me move this all the diagram towards the bottom, further uses. Then here look at here what is u, what is v, we know that already, right? What is f? So let me note down them. Here object distance will be measured between the p and o. That po gives you object distance as u something. Then image distance is what? p to I, that is given as v here. Next focal length pf1, that is measured as small f here. All the three measurements are noted. Then I required the relation between u, v and f. That is only here called as lens formula. Then to derive that one, just I am depending on the similar triangles. We have two pairs of similar triangles here. For that just you require to identify the angles. You know opposite angles are equal. Then you have the right angular triangles. Just find out here how many right angular triangles are there. There are 4 here. What they are? O dash P, P dash O dash, P dash F1, next P I dash. These are the right angular triangles. Right? So all these right angular triangles are said to be here similar triangles because the shape is same but size is different. They are said to be here similar triangles. If the shape and size both are same means they are called as congruent triangles. Okay, so here I will use the similar triangles. Let me identify them here. What they are here similar triangles? Triangle P dash F1 is similar to triangle F1 I dash. So where they are here, just let me take them. So I am highlighting that in the diagram P dash F1 and I dash F1 or F1 I dash, no problem. Right? So here highlighted that with yellow color and a light blue color. Look at the figure now. Now I required corresponding sides. Or you have a relation from the similar triangles that corresponding sides ratios are equal. So what they are here? That ratio we will write as here P dash by I dash. What that P dash and I dash here? Height of the triangle. In two different similar triangles here, right? So here in P dash F1, P dash is height of the triangle. In a triangle F1 I dash, that I dash also height. So that ratio is pp dash by I dash is equal to that corresponding sides ratio. That what another pair which makes the right angle here, that is base. So what we can write here, simply pf1 by f1i or if1, whatever it may be you can write. So I got. So this one just you have to give that i's equation 1. Let me write that i's equation 1 here. See here, just I am giving a number to that i's equation 1. So here this identified by me i's equation 1. Equation 1 is pp dash by I dash is equals to pf1 by f1i. Then here what you know pf1, do you know pf1? What you are able to write pf1 is equals to, or anything, it may be f1i. Are you able to write anything? It is pf1 measures the focal length. Okay, I know. What is pp dash? It is object height, because pp dash equal to o dash. It is the parallel distance. Yes or no? So I know pp dash also. What is I dash? I dash is
height of image.
Very good. So I know pp dash I dash pf1. What about f1i? We don't know. It is f1 to I. I know p to I. What is p to I? Image distance. pi is image distance. So here I know the total length and one of the part. So how to get the remaining part? I want to write f1 I is equals to. How can I?
Image distance minus focal length.
Very good. So we will write f1 I is equals to, that is pi minus pf1. This one highlighted in a triangle. So let me substitute that in the equation 1. What we will write? It is pp dash by I dash is equal to, we will write as here pf1 by f1 is replaced by pi minus pf1. Then I will get the next similar triangles that are here. Triangle o dash p is similar to the triangle pi dash. That corresponding sides ratios are same. That means here o dash by I dash. Just look at here. I am going to highlight that triangles for easy purpose. Okay, I got that highlighted triangles here. Look at them. Here what I will write, o dash by po or op is equal to, sorry, it's a corresponding side I dash, that is equals to basis ratio now, op by pi. So po written, then ratio between them is pi. So po by pi. Then here I know o dash, then I dash. There is no difference in that. So here simply I am replacing o dash. What is o dash? pp dash. Look at here, I replaced that o dash is equals to pp dash, because here it is the distance between two parallel lines here. That is what o dash, p dash and op. These are parallel lines. Then o dash and pp dash is the gap between the two parallel lines. Are they equal or different? They are equal. So we will substitute that o dash is equal to pp dash in the above equation what we are written previously, o dash by I dash equal to po by pi. Let me replace that one. So o dash replaced by pp dash here, by remaining are same, I dash is equals to po by pi. Now just observe the boxes here what I am showing you by joining together here. These two identify. Is there any similarity in them? See here in the both pp dash by I dash is LHS. In both same. So one of them is replaced by the other. So here what I am trying to write here, po by pi is equals to, here p dash by I dash replaced by pf1 by Pi minus Pf1. So I don't want this diagram here. I will minimize that one. So let me get that minimized image here. Okay, then I am going to write that relation mathematically what we have now. Okay, so here Po by Pi is equals to Pp dash by I dash, that is equals to here clearly I am showing. See here. Here I will write the reciprocal for this one. What we will write? If you apply the reciprocal on both sides, Po by Pi written as Pi by Po. Is it clear? Then what about right hand side? Pf1 by Pi minus Pf1 will be written as Pi minus Pf1 by Pf1. So here Pf1 is a common denominator for the numerator terms. That what? Pi minus Pf1. So I am going to separate that denominator for two terms in the numerator. So what we will write here? That is equals to Pi by Po is equals to Pi by Pf1 minus Pf1 by Pf1. So here Pf1 gets cancelled. What will be remaining here? Pi by Pf1 is minus 1, because Pf1 gets cancelled here. That remains as Pi by Po minus 1. So what I am able to write here? Pi by Po is equals to Pi by Po minus 1. Okay, so here simply I will take common here. What? See here, what we will write? Pi by Po is equals to, left side Pi is taken common. What is remaining here? 1 by Po. That is equals to RHS side also Pi I am taking common. What will be remains here? 1 by Pf1 minus 1 by Pi. This will remains. Is there any confusion? Is there any confusion? So in the next term, just I took common. What is that? Here simply Pi is common on LHS side and RHS side. So here if you multiply this Pi gets cancelled, remains as 1 here. I think it is clear. Then what is cancelled here? LHS side and RHS side we have commonly Pi, that will be cancelled here. Pi gets cancelled. Then see here what I am going to write here. 1 by Po is equals to 1 by Pf1 minus 1 by Pi. Then look at the denominators here. Do you know what is Po?
Object distance.
Okay. Do you know Pf1?
Focal length.
What is Pi?
Image distance.
Let me substitute them. If I replace that, definitely I will get the relation between object distance, image distance and the focal length. Is it clear? But remember one thing. Here I assumed a particular situation here, right? To generalize this relation for any ray diagram, we have to use rules of sign convention. We require rules of sign convention. So let me apply that rules of sign convention. Already I have mentioned in the figure what you are having on the screen now. Right side it is positive, left side it is negative. So who is on the right side? Focal length and image distance, they are taken to be positive, and image distance is left side, that is taken to be negative here. So here just before going that I am writing that what is just shifting. Yeah, Pf1 is keeping same side and Pi is taking inside. So what I will get here? 1 by Pf1 is equals to, I will get 1 by Po plus 1 by Pi. Just transposed, because I want to write 1 by Pf1 equal to. So here now replace them in the equation. What is Po? it is object distance measured left side. So it is negative, opposite in the direction of incident light ray, negative symbol. Then incident light ray direction, we are measuring image distance as well as the focal length here. So Pi is positive V and Pf1 is positive F. Then substitute them in the equation. What you got? 1 by Pf1 equal to 1 by Po plus 1 by Pi. So 1 by Pf1 is equal to F. So F1, Pf1 is replaced by F now. That is equals to 1 by Po. Here Po is measuring the object distance and it is given as minus U plus 1 by Pi, that Pi is replaced by V now. Then let me change the terms position according to that symbols. So minus written as second term here. So 1 by F is equals to 1 by V minus 1 by U. So this is the required equation for us. So this equation is called as lens formula. That lens formula will give you the relation between the focal length, image distance and the object distance. So this is the derivation of a lens formula.